Subtraction with mixed numbers. Okay, before we get into subtracting mixed numbers, we're going to just talk about a little bit of whole numbers. When performing subtraction, if the bottom number is larger than the top number, it is necessary to borrow. Example, 53 minus 27. 7 is larger than 3, so we have to borrow, right? So we borrow from the 5. Since 7 is greater than 3, we borrow 1 from the 5 and write it in front of the 3, and then it becomes a 13, right? So borrow 1 from the 5, it becomes a 4, you put a 1 in front of the 3, and then we consider it as a 13. So 13 take away 7 is 6, and 4 minus 2 is 2. Okay, and why does it become 13? Because that 5 is in the tens place, so we're adding a 10 to the 3 to become 13. So we borrowed a 10 actually. Okay. So in this section of subtraction with mixed numbers, the process of borrowing will again be necessary when the bottom fraction, so when the bottom fraction is larger than the top fraction, that's when we're going to need to borrow. And again, so think about that. We borrowed a 5, we changed it to a 4, so we had to decrease it by 1, and then we placed it in front of the 3 because we borrowed from the tens place. Okay, so in this section we're going to borrow from the ones place and then add the 1 to the fraction. So we won't be adding a 10, we'll be adding a 1. Okay. Now, adding 1 to a fraction. So we just talked about that we're going to be adding 1 to a fraction, right? Let's just talk about 1, or specifically fractions that equal 1. Any fraction with a non-zero denominator that is equal to its numerator is equal to 1. So we said non-zero denominator. That means the denominator can't be 0. What is a fraction called when the denominator is equal to 0? That's right, undefined. When the denominator is 0, it's called undefined. When the numerator is 0, it's called 0. But when the denominator is 0, undefined. Okay, that was from a previous video, but we're not talking about that right now. Just kind of a side note. So any number over itself, like 8 over 8 is equal to 1. 245 over 245 is equal to 1. Even in algebra, x over x is equal to 1. Okay. So here's our first example. We're going to be adding 1 to a fraction, right? So let's talk about that. Let's add 1 plus 5/12. We don't want to write that as a mixed number. We want to write it as a fraction. So I wrote in parentheses here, do not write as a mixed number. Well, I could have also wrote that as write as an improper fraction. Okay. Well, I could write 1 as any number over itself. I could write it as 8 over 8. True? But then we would have to find a common denominator. Well, why not use the same denominator? So since the denominator of the other fraction is 12, why don't we write 1 as, yeah, you got it, 12 over 12. So 1 is 12 over 12, and then we could add that to 5/12, and that gives us 17/12. Okay, so we added 1 plus 5/12. That was just our job. We're going to get to mixed numbers in just a little bit, but this is just getting us ready to subtracting mixed numbers. Okay, now there's also an alternative method, and I kind of like this one a little bit more. 1 plus 5/12. Well, that 1 plus 5/12, that plus really isn't even necessary. That's the same thing as the mixed number 1 and 5/12. Yeah, it's not when you have a whole number and a fraction right next to each other. As long as you don't see a dot in between to show multiplication, it means it's a mixed number. So if you saw a dot in between, then that would mean 1 times 5/12. But if there's no symbol in between, it means 1 and 5/12, the mixed number. Well, now how do you change that to an improper fraction? Well, multiply the whole number in the denominator and then add the numerator. So 1 times 12 is 12, plus 5 is 17, and then add the numerator. So you get 17/12. Yeah, I kind of think that was a little bit easier, but it's really your choice. I really like the second one. Okay, let's go on to the next one. Try another. 1 plus 3/8. Again, same directions. Do not write as a mixed number. In other words, write it as an improper fraction. So 8/8 plus 3/8, which is 11/8. Or 1 3/8 will give you, change it to an improper fraction, 11/8. So either way, it's the same answer. Okay? Alright, here we go. Ready? Yeah, you're ready. Procedure for subtracting mixed numbers. Rewrite the problem vertically, aligning the whole numbers and the fractions. Just like adding mixed numbers, we're going to rewrite it vertically. Number 2, we're going to subtract the fractions if the top fraction is larger. Okay, but we have an issue. If the top fraction is smaller, if the top fraction is smaller than the bottom fraction, then we're going to have to borrow a 1 from the top whole number, and then add the 1 to the top fraction. Write it as an improper fraction. Then subtract the fractions. Okay, so one way or another, we got to subtract the fractions. And then we can subtract the whole numbers. Okay, so you might want to pause the video, make sure you write down all your notes in your notebook. Okay, let's get started. 12 and 5/7, and as always, our first example is not too bad, and then they get better as we go along. So let's write the problem vertically. Okay, the denominators are the same, so we could subtract the fractions. There's also no need to borrow in this problem because the top fraction is larger than the bottom fraction. So we could go ahead and subtract 5/7 minus 2/7. So subtract the numerators. 5 minus 2 is 3, so that would be 3/7. And then subtract the whole numbers. 12 minus 5. So next is, after subtracting fractions, then we could subtract the whole numbers, which is 7. And we're all done. Can't reduce. Our fraction is not reducible, so we're all done. Okay, we could do better. 18 and 3/8 minus 13 and 5/8. Okay, let's go ahead and rewrite the problem vertically. Okay, Notice when I wrote the problem, I kind of left some space because you could already see we're going to have to borrow. Um, you got to have a little space for that 1 or the 8/8, whichever one you want to use. So just when you're writing this in your paper, try to use plenty of space. Try to be neat about all your work. Sometimes people try to use as little paper as possible, but then you can't read what you're writing. So try to use space. Go ahead and use a little bit of paper there. Use plenty of scratch paper. Okay, so we have to subtract, we want to subtract fractions, right? But the bottom fraction is larger than the top fraction. We cannot subtract 5 from 3. So we're going to have to borrow from the 18. So it says borrow a 1 from the top whole number, add a 1 to the top fraction, write it as an improper fraction, and then subtract. Okay, so the 18, we're going to subtract a 1 from the 18. So the 18, I'm going to mark out the 18, and that becomes a 17. And then I like to just put a 1 in front of that 3/8. Not in front of the 3. Don't make it a 13. That would be wrong. So that's crucial. Sometimes people make a mistake and put it right in front of the 3. Put the 1 in front of the whole fraction, 3/8. Okay. Now we have to write it as an improper fraction. Well, 1 times 8 is 8, plus 3. What does that give us? 11/8, right? So let's rewrite it. We have 17 and 11/8, and then the bottom is 13 and 5/8. If you didn't write the 17 over again and 13, that's no big deal. I just have to write it over to be proper here. Sometimes it's, if you just kind of don't write that and just subtract it over to the left, that's fine. So 11/8 minus 5/8. Now we could subtract, right? 11 minus 5 is 6, so that gives us 6/8. And then we could subtract the whole numbers. 17 minus 13 is 4. Are we all done? Almost. You just have to reduce that fraction. I'm sure you didn't miss that, right? 2 goes into both those numbers. So 4 and 3/4. Alright, let's do another one. 40 and 5/7 minus 15 and 1/2. Oh, we could already see some other issues here. We have different denominators this time. Okay, let's go ahead and write down the problem. Rewrite it vertically. Okay, so our LCD, what number does 7 and 2 both go into? Well, we're going to subtract a fraction, so 7 is just 7 and 2 is just 2, so our LCD is 2 times 7, which is 14. Probably didn't even need to write that down, right? Okay, so we're going to rewrite it over again with our common denominator of 14. And then find our new numerators. Let's see, 7 times what number is 14? And then multiply the same number by the 5. And 2 times what number is 14? And multiply the same number by the 1. So that'll be 5 times 2 and 1 times 7. So we got 10 minus 7. Right, so now we can subtract, and that gives us 3/14. Remember, you always have the ability to just pause it and work it out if I go too fast. Maybe some people are just kind of going through it because they've already seen the video before. So just pause all the time if I go too fast. Now we can subtract the whole numbers. So that's 25 and 3/14. Are we all done? Yeah, we're all done. We can't even reduce, so that's it for this one. 25 and 3/14. Okay, let's do the next problem. 97 and 1/12 minus 43 and 7/16. You might want to pause. I think you could probably do this one on your own. This one looks like there's going to be some borrowing involved. Okay, here we go. So let's, step one, write it vertically. We're going to have to write it as equivalent fractions to subtract. So 12 is 2 times 2 times 3, and 16, there's 4 2's. So our LCD, we're going to have 4 2's and 1 3, which gives us 48. Okay, so now we'll write the problem over with the new denominator, and then figure out what our new numerators are by figuring out 12 times what number is 48, and 16 times what number is 48. And use our numbers to the right. Let's see, 12 is 2, 2, and a 3, so in your LCD, if you cover up 2 2's and a 3, we'll still have 2 2's left over, so that's 4. So 1 times 4, and 16 is 4 2's. So if you cover up 4 2's in the LCD, you'll have a 3 left over, so it's 16 times 3. We have 4 and 21. Okay, so there's some borrowing here. We cannot subtract 21 from 4, so we're going to have to borrow a 1 from the 97. And then we're going to add that 1 to the fraction, and then change that fraction into an improper fraction, and then we could subtract. Okay, always like pause, work it out. Everybody takes their own, everybody takes a different amount of time to work something out, so always keep pausing and work it out on your own. Okay, so subtract 1 from 97, that gives us 96. Put the 1 in front of the fraction, not in front of the 4, but in front of the whole fraction. And that becomes 52 over 48. And now we could subtract. 52 minus 21 is 31. And then we could subtract the whole numbers. Gives us 53. And 31 is a prime number. So that's it. 53 and 31 over 48 is our final answer. That was a nice one. Okay, 2 more problems to go. These last 2 aren't that bad actually. They're real short, so don't worry. 18 and 5/7 minus 12. Rewrite the problem vertically. Okay, now subtractive fractions. Is the top fraction smaller than the bottom fraction? Well, there isn't even a bottom fraction, right? So we could just 5/7 take away nothing is just 5/7. So you just get 5/7. And then 18 minus 12 is 6, because we can subtract the whole numbers now. And that's it. So when there's a top fraction and no bottom fraction, you can just bring down the top fraction. That wasn't too bad. That probably won't be on the test. Just kidding. Okay, let's go on. Okay, this one's a little different. 25 minus 3 and 5/16. Okay. Rewrite the problem vertically. Okay, now we want to subtract the top fraction minus the bottom fraction, but there is no top fraction. And it says that if the bottom fraction is larger than the top fraction, we have to borrow. Okay, so let's read what it says here in step 2. In this problem, the bottom fraction is larger than the top fraction. So we then need to borrow a 1. Also remember that 1 can be written as any number divided by itself. Remember 8 over 8, or 245 over 245. Since the bottom fraction has a denominator of 16, we will write the 1 as 16 over 16. Okay, so I don't know if you follow that, but see, our bottom fraction is 5/16. That's larger than the top fraction, which is nothing right now. So we need to borrow. We need to borrow a 1 from the 25. So we're going to borrow a 1, and we're going to put that 1 where the top fraction is supposed to be, or isn't. And you can write that 1 as any fraction over itself. You could put an 8 over 8 where that top fraction is. But because the bottom fraction has a denominator of 16, we don't want to use 8 over 8 because then you have to get a common denominator. We want to use the same denominator. So we'll write that 1 as 16 over 16. So borrow 1 from the 25. That becomes 24. And then we'll put a 16 over 16 right there. So whatever the denominator is from the bottom, that's what you're going to write the fraction as. If that denominator was 11, you would write 11 over 11. Okay? And now we can subtract. So 16 minus 5 is 11. So we have 11/16. And then 24 minus 3 is 21. And we're all done. 21 and 11/16. Okay, so the last example, in example 7, if the fraction was on top, you can just bring it down. That was the easy case. If the fraction is on the bottom, then you have to borrow 1 from the top number, and then put a fraction of whatever that denominator is over itself. Okay, so just notice those two examples. One of them, no work, very easy, just bring out the fraction. The second one, a little bit of work, but not too bad once you know how to do it. Okay, that was the last video. Okay, hope you have a good day.